Okay, Hallie, we are doing the chapter review on Friday. We did, which I just sent to you, was the chapter, was the review part B, because part A, I am working on uploading it right now. But part B of the review had number 19 and number 20 on it as well. We're gonna do the review 1 through 18 today. We're gonna test tomorrow over chapter 4. On the test, you get to use this little cheat sheet, which I'm still working on sending to you. Otherwise, I might just have you get that from somebody else, along with the backside here. And yeah, that's what you get to use on your test. I probably am not going to make you take this test tomorrow, though, because you, like, yeah, who knows. All right, chapter 4, number 1. The following data, we have a two-way frequency table. It's not set up in table format, but I'm going to put like the table in here, blah, blah, blah. And then let's do the total rows. So totals here, totals here. Number of flights which were on time. We had 76 flights on time. We had 11 flights that were late. Yeah? Of those flights, Podunk Airlines, there was 39 flights that went out of Podunk Airlines, and Upstate Airlines, there was 48 that went out of Upstate Airlines to make a total of 87. Yep, 87 airlines total. Yeah? There's my table that I have going on here. All right, here we go. They want us to find the probability. I'm just going to go down to this last little piece. Find the probability of on time and Upstate Airlines. We're selecting 2 airlines, okay? And means we're multiplying. 2 airlines, 2 or more events means we're multiplying. So this one times this one, all right? And if one flight is selected, oh, wait, wrong. We're studying the 2 airlines. We're only selecting one flight. If one flight is selected, find the probability that they are on time and Upstate Airlines. Okay?
So on time.
Yeah, but we're only selecting one. So they want to know, like, of this table, which number is on time and Upstate?
43.
The 43. On time and Upstate is 43 out of 87. That was tricky. Okay? One flight. That's how you know. We're only picking one flight.
Do they use the review or just the cheat sheet?
Both.
I mean, you can use a review, I guess, if you think it'll help.
It'll probably help.
You think it'll probably help?
It'll probably
If you fill it in.
I'm filling it in.
Are you filling it in? Okay. Number 2, a firm uses trend projection. This is like the 4-5 stuff, which is using simulations. Says trend projection and seasonal factors to estimate sales. A 0 is sales falling. A 1 is if sales are steady. 2 is if they're rising moderately. 3 is if they're rising a lot. So the simulator generates the following output. So 0 is falling. 1 is staying the same. 2 is rising. 3 is really rising. Okay? So we've got this going on here. Estimate the probability that sales will rise at least moderately. What does that mean we're looking for?
At least.
At least moderately.
So 2 or 3.
We're looking for 2s or 3s. That make sense? Okay, how many do we have total? Does it say?
I counted 31.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. My eyeballs are hurting. 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. I counted 31 as well, right? So we're looking at 2s or 3s. Now, or means add, right? Or we could just count 2s and 3s together. There's 16 2s or 3s. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. That's what I got as well. 16 over 31. Okay, that are 2s or 3s. We're adding the 2s and 3s together, right? Yeah? Okay. All right, here's another frequency table. We've got this going on here. I'm going to add my totals. So 122, we've got 21, we've got 115, we've got 28, and a total of 143. Is that true? I think. Subject has the disease, positive test results, whatever. If one of the results is randomly selected,
So one event.
one event, okay, what is the probability that it is a false negative? Which means the test indicates the person does not have the disease when in fact they do. probability that the test indicates that the person does not have the disease when they actually do. So probability of getting a positive given they have the disease. Do you see how that works out? Test indicates that the person, does not have the disease. Sorry, it should be a negative.
4 out of 143.
Negative right here. Negative, given that they have the disease. Yeah? That's how I separate that out. Negative, given, have. Has is 115. Yeah? And negatives is 4. 4 out of 115, is that what you got? Yeah? Okay. Do we see how that is read? I take it from the paragraph and I write it in that notation. That's how I do it, usually. Did we do that right?
Hope so.
Rem's looking at it weird.
I don't know, because wouldn't a false negative be out of everything? So wouldn't it be out of 143? Why is it out of 150?
But has.
No,
the
because the
indicates
negatives
person
don't
does
have
not
the disease
have the
isn't a
disease
false
when
negative.
infected.
Right. Yeah, the ones, that wouldn't be out of the total. It would just be out of the ones that
But
have.
Because
what
the
tells us
fraction
it's out
bar
of
is the-
115?
fraction
Because
bar is the given.
when in fact they do, we're looking at only the people who do have the disease. Yeah.
Because if you took something that wasn't.
Because out of the, like if they tested negative and they didn't have the disease, that would be a true negative, right? We only want the false negatives.
Okay.
Yeah. Okay. Was that confusing?
No.
Okay.
I get it.
Flip a coin twice. Create the sample space of possible outcomes. If we're flipping the coin twice, we could get a head, a head, tail,
There's a second part to three.
tail, head, tail. There's a second part. What does this probability suggest about the accuracy of the test? 4 out of 15. These are giving me false results, right? That's like, I don't know, what percent is that?
3%,
Is it 2%?
So
Something
mine's
close.
pretty accurate.
3%, 3.5.
That's 3.5%.
3.5%. So we have a test that's like 96.5% accurate. That's okay. Decent test.
Take it twice and you'll be fine.
Yeah, right. Yeah, do that redundancy and it would work. Yeah, that's not bad false negatives, honestly. Yeah. Okay, yeah, sample space for number 4, list of possible outcomes. How do I know that there's only 4 in that thing?
Squared.
Two coin flips. There's 2 in this outcome, like heads or tails, so that's 4 possible total outcomes, right? If I was flipping the coin 3 times, it would be 2 times 2 times 2, so it'd be 8 in that list, right? That's how you know that you have all of them. Questions about that? Make sense? Okay, we are batting in the next question. 1 is a hit, 0 is an out. Now, the reason why they use 1s and 0s instead of like 1s and 2s or 2s and 3s or whatever, right? If you're running a simulator, 0s and 1s are very easy for you to pick out visually. Does that make sense? I think I've said that before, but like when you're running a simulation, 1 versus 2, like the 2 has a vertical line here, so sometimes people get like when they're trying to go fast, they don't see the 1s and 2s as easily, right? Versus 0s and 1s are a lot easier to pick out.
And don't
Right.
confuse like talking zeros and ones.
Yeah,
That's
yeah, like
different.
coding. Yep. So 1 is a hit, 0 is an out. They want to know, estimate the probability that we get the hit. So probability of hit, 20 out of 42. So 10 out of 21. Did we reduce? Something like that. Okay. If you want to give it to me as a decimal, that's fine. I don't care. I don't care what currency the answer is in. Either fraction, decimal, percent, I don't care. Okay, 6. They're giving me a list. I'm going to list. There are, in certain classes of students, there are 11 boys from Wilmette and 7 girls from Wilmette. 5 boys from Winnetka and 4 girls from Winnetka. 4 boys from Glencoe, 4 girls from Glencoe.
No.
How the heck do we do this?
Make a table.
Yeah, let's make a table. I'm going to put my table down here.
So girl, boy.
Yeah, I'm going to go girl, boy, like here. Girl, boy, and then I'm going to go, we can't even do W. I'm going to do W-I-L, W-I-N, and Glencoe. Let's do that. Like 2-way for. So if we have 3 different people across the top, 3 different schools, this is the best way to organize your information. Yeah. But it is. Okay. 11 boys from Wilmette and 7 girls from Wilmette, 5 boys from Winnetka, 4 girls from Winnetka, 4 boys from Glencoe, 4 girls from Glencoe. If the teacher calls upon a student, let's do our totals first. That's 18 total from Wilmette, 9 total from Winnetka, and 8 total from Glencoe. Girls total is 15, I think.
15,
20 boys total, so 35 kids. All 3 places together. If the student calls upon somebody to answer the question, what is the probability that the student will be a boy? Probability of boy. That's not like boy given anything, that's just probability of boy. So we're going out of the total, so 35, so 20 out of 35, or if I divide by 5, that's 4/7, or whatever, if you want that as a decimal, okay? I strongly encourage you to, like, when they give you story problems like that, like, write it down as a table, or do something like that, okay? Assume that a study of 500 randomly selected airplane routes show that this many arrived on time. Select the correct interpretation of the probability of an airplane arriving late. Interpret an event as significant if the probability is less than or equal to 0.05. That was a lot of information all at once. Okay, so I'm going to do this. Because I need to, like, organize my thoughts, I have 500 selected airplanes. Oh, I don't need a two-way frequency table. We're not talking about 2 different airlines. We're talking about late or on time, right? 482 arrived on time. Select the correct interpretation of airplane arriving late. So 482 out of 500 was on time. That was what percent? Somebody give it to me.
well, as a decimal, it's 0.964, so it'd be
0.964. So that was on time, right? So late will be what? 1 minus that, so 0.036, right? Or in other words, that's 3.6% is arriving late. Now, do you know what we did there? What strategy did we use on that one? What's the subtraction one called? What? The complement. We used the complement, right? So 3.6% arrived late. It says, select the correct interpretation of the probability of the airplane. Okay, interpret an event as significant if it has a probability less than or equal to 0.05. So is it rare? Is it rare for, or is it a significant event for a plane to arrive late?
No. It's insignificant.
Is that 0.05%, or is that just?
No, that's 5%. If it has less than 5% chance of happening, right?
Okay, then it
We good.
Is it rare? Is it significant?
Yes.
Yes, it's significant. Like, they have such a low rate that they have a low rate of late planes arriving that if I am on a plane and it is late, I would be like, holy crap, I really had bad luck today. Because I was on one of the very few that were late. Does that make sense? Okay. So when you see that word significant, sometimes I insert the word significant with rare. Like, is it rare to happen, right? It's rare if it happens less than 5% of the time. Does that make sense? So significant, rare, yes, it is. Yeah?
Yeah.
Confusion? Okay, number 8, determine whether the events are disjoint. What does disjoint mean?
Not related.
Like this going on here. That's the visual that's in my head when I see disjoint, right? They are not connected. Like males and females don't, okay, maybe I shouldn't use that. Juniors and seniors. You can't be both, right? Okay? Mark Twain and a book about Tom Sawyer.
Not disjoint.
Not disjoint. Mark Twain is the one that wrote Tom Sawyer. True?
Yes.
Okay, so like they're connected. This is doing this, right? So they are not disjoint. Not disjoint. They are joined together or they are inclusive events. Inclusive. Maybe write down like disjoint equals exclusive. Exclusive. They exclude one another. If they are disjoint, they're not joined, right? This one is not disjoint or inclusive. Okay? All right, this one is kind of silly. Evaluate the expression 8p4. If you type 8p4 into your calculator, what do you get?
1,680.
1680. And that is what? The number of combos for choosing. How many?
4,
4 out of
8.
Where the order matters.
8 when order matters. I like it. That is the explanation. Choosing 4 out of 8, order matters. It's the number of combos I can get. Okay. Good?
Yeah.
Okay. 10. Ugh. 10 is an icky one, I think. A study conducted at a certain college shows 65% of schools graduates find a job in their chosen field. So, probability of find job equals 0.65. Probability of not find job
0.35.
is 0.35. I haven't even read the whole first sentence and I'm writing that stuff down. Okay? Now, that's not to say that they didn't find a job. They just didn't find a job in their career path. For example, I had a friend who, what?
Within a year.
Within a year, yes. So I had a friend who went to like UNK and got a degree in like business something or other, and then he came back and he worked for my husband in construction. And he did not need that degree to work with my husband in construction, but he was making a lot more money than he would have if he was working in his career field. So you people who are going to college, be wary of that. Like, don't spend money on a degree if you're not going to actually use that degree. I mean, maybe you're just there for the college experience, and that's fine if you want to spend oodles of money for that. But, like, make sure that you actually need the degree for something that you're wanting to do. I don't know. Whatever. That's my 2 cents on that. All right. Find the probability that 11 randomly selected graduates all find jobs in their chosen career field within a year of graduating. 11 of them. So I have 11 people standing here. Blah, blah, blah. A ton of them. Like, what's the chances that this first one gets a job in their career field? 0.65. What's the chances that the second one gets a job in their career field? 0.65. 0.65. 0.65. What do I do at the 0.65?
5 to the 11.
0.65 to the 11th power. What's the chances that all 11 of them?
0.00875.
Woo! 0.00875?
So,
Yeah.
as a percent, that would be
0.875.
That would be 0.875. That's less than 1%. Yep. Less than a 1% chance. That seems pretty low,
I
but
will say that's
only
probably not
65%.
very, yeah, accurate.
You don't think so?
Because, yeah, like when you go to colleges, on college visits, they say like you're guaranteed whatever, like,
Right.
you'll get a job, but yeah.
But not always for that.
Yeah, but not always for that thing, right?
And
Not
it
always for that.
depends if these are like, they graduate with their bachelor's, but they need their master's to get the
True.
job that they want.
Oh yeah, they
Or
might be.
no.
They might be
You
included
get
in
a
that too.
bachelor's in psychology,
Yeah,
you
I would
can't
say
be a
like college,
psychologist.
like
Or if it's
bracket,
like
they
higher
can
ed.
get
Right.
Yeah.
people jobs within.
Right,
that year.
right. Like they told me that when I went to that engineering thing, that 100% of the graduates the previous year got jobs in engineering.
Can we just finish this
I'm like-
review?
What? You be nice.
No.
Okay. We'll just go as slow as possible. All right. Okay, this is a very interesting question. All right? Make sure you read it correctly. Express the indicated degree of likelihood as a probability. Okay, remember that probability has to be a number between 0 and 1, right? Can't be negatives, can't be numbers higher than 1, any of those. Your mother could not have died 2 years before you were born. If we're talking about the
Negative.
probability of your mother dying 2 years before you were born, what is the probability of your mother dying 2 years before you were born? 0, right? That is true. She can't die 2 years before you were born because then you wouldn't be born, correct? Yeah? Now, yes, this was probably like done before the IVF thing happened. There is that.
She was dead, but they kept the baby in there for a while, and then they gave birth to the baby, but she was actually dead. They just kept her as like an incubator.
Right, but that wouldn't be 2 years though.
They could do
But
it.
also you have like IVF going on, right? So like they had like a couple instances just recently of like the baby was older than the mother because the egg from the baby was actually like put in the freezer before the mother was even born, and like she adopted that egg.
This is stupid. Can we keep going?
I'm just saying. So, excluding those rare things that happen, probability of her dying before you were born is 0. Okay, because 0 is the probability. All right, here we go. We've got these guys. I'm going to make them into a table. I don't know if I need all the totals, but I'm going to do them anyway. This is 114. This is 321. This is 96. I don't know if I'm doing these right. This is 339. And the total is 535, I think. Yes.
Yeah.
Okay. Yeah.
No,
Yeah.
435.
435.
I can't math. 435. Yes, correct. 435. Okay. A test subject is randomly selected and tested. A test subject. So we're only doing one, right? What is the probability that the subject has the disease? There's that word given, that the test result is negative. So probability, we're doing, I write out the like shorthand. Probability that they have the disease given that the result is negative. Because then it makes it easier for me to see what we're doing, right? The bottom number is going off of just the negatives, right? So what's the bottom number going to be?
321.
321. Now, of those 321, how many people have
9.
9 out of 321? So that would be like a false negative, right?
Yeah.
Okay, which is, I don't know what percent, like
2.8.
2.8%? Something like that. Okay, good.
Yeah.
I really suggest that when they write it out in the paragraph, put it in the shorthand and then you can see it a little bit easier. Yeah? Okay, next. Of the 1232 people who came into a blood bank to give blood, that sounds like an N. 1232. 397 people had high blood pressure. I don't know, that might be an R. 397 had high blood pressure. Estimate the probability that the next person who comes in will have high blood pressure. Oh, that was silly. What's the probability that they will have high blood?
397 over 1232.
397 over 1232.
So you didn't need that.
No, not really. What is it?
32%.
32% chance that they will have. That's insane. 32% chance that they will have high blood pressure? Oh my Lord. High blood pressure? Good grief. Okay. The table shows soft drinks. Do I need?
Ew.
Yeah.
Yeah, we need totals. Boo. Okay. We've got 95. We've got 75. We've got 85. I think. Under 21 years old that's 85. This is 85. This is 85. 85 times 3 is 5. Carry the 1. 255. I think. Yeah. Oh, yeah. If one of the 255 subjects is randomly selected, find the probability in fraction form that the person is over 40 and drinks cola. Over 40 and drinks cola. Who's that person?
20 out of 95.
Just this person. Over 40 and drinks cola. 20 over 255. Yeah. Which, if you divide, is 4 over 51. Yeah.
Why isn't it 20 over 95 if they just drink cola?
Because you're going out of all of the 255. So it's not given that they drink cola.
Drinks cola.
It's this is the only 20 is the only number of people that are over 40 and drink cola out of the total. Okay, it wasn't a given.
And it says one of the 255.
If one of the 255, so 255 is your bottom number, yes. I think you were going given. You were thinking that this said given instead, in which case you would be right, okay? All right, in one town, 66% of adults have health insurance. So probability of have is 66% or 0.66, 0.34, no have. No health insurance is 0.34, have health insurance is 0.66. What is the probability that 4 adults selected at random all have health insurance?
So 0.34.
First person, second person, third person, fourth person. What's the chance that the first person has health insurance? 0.66. Second person, 0.66. 0.66. 0.66. So 0.66 to the fourth power.
18.97%.
18.97 if you put it as a percentage, which is fine. Okay? Good. If a person is randomly selected, find the probability that his or her birthday is not in May. Okay, this is one of those complement things, right? Instead of adding up all the other months, how many days are there in May? 31 days in May. May equals 31 days. So, days total would be 365. I'm going to subtract my 31, so 334. So, what's the chances that they are not in May? 334 over 365. And they say ignore leap years. So you could leave it like that, or you could give it to me as a decimal, which is going to be like 90%. not quite 90%, 85%,
91.5%.
91.5%. Okay, there you go. Either way. Okay, compare probability and odds. Okay, probability. What is probability asking for?
34, 50, 65, like a fraction.
Like a fraction? Well, odds is kind of, you can make it into a fraction though. What's the difference between probability and odds? Odds, a lot of times they'll use a colon. Or they can use a top and a bottom number, doesn't matter. Probability is what?
N over total.
What you want over to the total, right?
And then
Okay. Odds is
want versus don't.
want versus don't want. Want versus don't want, right? How can you convert odds to probability?
If it's like 3 to 4, you would do like, it'd be 3 over 7.
Yeah, you would add the two parts together to get the total. Something like that, right? For probability. Okay, so like you said, 3 to 4 odds would be 3 over 7 total, right? Because 3 to 4, you would add them together. Those are my parts. Add the two parts together to get your total number for your probability. Okay? Discuss the range of possible values for probabilities.
0 to 1.
0 to 1. Or 0 to 100%. This is for decimal form. Decimal. 0 to 1. Give examples to support this.
0.6%.
Number 11.
What?
Number 11. We talked about.
Yeah, number 11. Yeah. Like the one up here, your mother couldn't have died, whatever, before. Give examples to support this.
I'm just putting number.
I don't know.
Just write
I'm going
number.
to say probability of rolling a 7 would be 0 on a dice.
What if it's one of the
Rolling a number 1 through 6 is 1, right?
What kind of dice are
given that they're normal dice?
Rolling an even, yeah, given that they're normal dice. Rolling an even is 1/2. All of those things are between 0 and 1, right? The probabilities.
I just put number 11.
Okay,
Me too.
sure, number 11 works. Okay, good.
I'm gonna put that on the
Woo!
first tomorrow, too.
All right, there you go. You think so?
Yeah.
Okay,
You should be
beautiful.
19.
What did they say? Oh, number 18. Probabilities range between 0 and 1. P of 0 means that event A will not occur. For example, the probability that Thanksgiving will be on a Monday. P of 1 is certain to occur. Probability that it's on a Thursday, that Thanksgiving's on a Thursday. Other probabilities occur between these two values. The probability of 0.5 is an equal chance of occurring or not occurring. So we did the same thing. We did a 0, a 1, and a 1/2, right? Something like that. Good, good. What do we need to go to?
Those two.
Those two.
Thank you. Oh, yeah, yeah, yeah.
Okay.
There you go.
All right. Okay, I'm going to stop the recording now. Goodbye.